Did you know that every year, the global fast food industry generates over $1 trillion in revenue? An economic machine so massive it surpasses the GDP of Switzerland? Among its most recognizable players are KFC, known for its fried chicken with a crispy golden crust and tender, hot, flavorful meat inside. McDonald's, with hamburgers standardized down to the millimeter. And Domino's Pizza, where pizza bases are industrially produced and delivered hot, minute by minute. Today, join Agriculture Insight as we step inside the colossal fast food factories, places where dishes that seem deceptively simple are actually created by some of the most complex production systems in existence. From these modern facilities, fast food crosses cultural borders and geographic distances, quietly weaving its way into every street, every neighborhood, and nearly every corner of the planet. Compared to most other fast food items, the hamburger is one of the world's most powerful profit-generating machines, thanks to its low production costs, extreme standardization, and ultra-high service speed. As a result, this seemingly simple sandwich can be replicated tens of billions of times each year, giving rise to a global business empire valued at over $300 billion. The journey of making a burger begins inside massive industrial mixers, where flour, yeast, water, sugar, salt, butter, and eggs are adjusted according to McDonald's proprietary formula, a system of ratios that exists only within internal production specification sheets. Inside the factory, the dough is never kneaded by hand. It is pressed, stretched, and twisted by machines capable of handling 1-2 tons per batch, spinning at over 100 revolutions per minute. After mixing, the dough is transferred to a controlled proofing stage, where the temperature is maintained at around 30 degrees Celsius and humidity is kept stable to allow the yeast to perform at its optimum. Next, the dough is automatically divided into precise portions, typically ranging from 60 to 70 grams, a figure carefully calculated so that, once baked, each bun reaches a diameter of about 10 centimeters, fitting perfectly with a standard hamburger patty. Before entering the oven, the surface of the buns is misted with steam and coated with a thin layer of egg wash, creating the signature golden color. In less than 12 minutes of baking at temperatures above 200 degrees Celsius, thousands of identical buns are completed, uniform, precise, and ready for the next stage of the production line. Once cooled, the buns are cleanly split in half by an automated slicing machine, ready for the packaging stage. The bun halves are then placed onto conveyor belts, neatly aligned and sealed using airtight packaging systems, helping preserve freshness and optimal flavor. In a hamburger, cheese is not just added for richness, it is engineered to melt at precisely the right moment. Most major burger chains use processed cheese, often based on cheddar or American cheese, enhanced with emulsifying salts to control its structure when exposed to heat. As a result, the cheese begins to soften at around 60 degrees Celsius and fully melts at approximately 75 to 80 degrees Celsius, evenly coating the patty without separating into oil or clumping. A change of just a few percentage points in moisture or fat content can cause the cheese to melt too quickly or unevenly, disrupting the familiar smooth, creamy sensation of a perfectly made hamburger. Once the buns are completed, the production line immediately shifts to preparing the meat patties. On a parallel processing line, the patties are handled within a closed system, beginning with the selection and cutting of beef into standardized sizes, before being fed into high-capacity grinders to create a smooth, uniform mixture. What few people realize is that each patty does not come from a single cow. Rather, it is the result of a carefully controlled blend from around 200 cattle per day, designed to lock in flavor and ensure that every burger leaving the factory delivers the same familiar taste. Once the meat mixture reaches a smooth, cohesive texture, it is fed into patty-forming machines, systems programmed with near-absolute precision. Here, the meat is pressed into perfectly round patties, with thickness and structure tightly controlled. Pre-calculated pneumatic pressure ensures each patty is firm to the touch without cracking or breaking. Immediately after shaping, the patties are sent through a rapid chilling stage where powerful streams of cold air reduce the temperature to around 0 degrees Celsius in just 3 to 7 minutes. This process locks in the meat's structure, preserving moisture and ensuring an ideal tender texture when the patty is later cooked. When all the ingredients are ready, a McDonald's burger begins to be assembled through a process that has been standardized to near perfection. The bun is placed onto a hot grill for just a few seconds, enough for the surface to lightly toast and release its signature buttery aroma, while the inside remains soft and familiar. A layer of McDonald's signature sauce is applied with precision using a calibrated dispenser, just enough to bind the components without soaking the bread. Next, the layers are stacked in a pre-programmed order. Finely shredded lettuce for a fresh crunch, evenly sliced pickles for that familiar tang, a perfectly cooked beef patty, and on top, a slice of cheddar cheese that melts at exactly the right moment. Not too early, not too late. The entire process takes only 30 to 40 seconds, yet the result is a burger with a consistent flavor profile, whether you take a bite in New York, Tokyo, or Paris. That is how McDonald's turns a simple burger into a global product. We leave behind the McDonald's factory, where hamburgers are replicated every second. Next, we turn to another empire, the world's most globally widespread fried chicken chain, operating a machine worth tens of billions of dollars each year, KFC. The journey of KFC chicken begins at dawn, when refrigerated trucks carrying fresh poultry leave the farms and head straight to the processing plant, where every step is timed down to the second. Upon arrival, the chickens are pre-cleaned and immediately fed into an automated production line with almost no downtime. Within minutes, they reach the leg separation area, where industrial cutting blades, calibrated to match the natural structure of the joints, operate continuously at a capacity of around 10,000 units per hour, ensuring uniform sizing. The carcasses are then transferred to the evisceration stage, where vacuum-based systems remove the internal organs in just 3 seconds. The pressure is precisely controlled, strong enough to clean thoroughly, yet gentle enough to preserve the integrity of the meat, marking a critical step in maintaining hygiene, quality, and consistency before the chicken moves on to the next stages of processing. Immediately after the initial cleaning and sorting stage, the chickens are transferred to a dedicated wing cutting line. Here, each bird is placed into a mechanical positioning mold that holds it in the correct orientation before automated blades make precise cuts at the wing joints. This entire section is designed to operate continuously in production shifts lasting up to 18 hours per day, ensuring a stable supply for thousands of restaurants across the same region. Once separated, the wings are moved onto a separate conveyor for inspection and classification. The remaining carcass then enters the central processing line. Throughout this sequence, from halving the body to separating the breast and sorting the thighs, the ambient temperature is maintained below 10 degrees Celsius to slow microbial activity and preserve the meat's structure. The body is split along a fixed axis, the breast is removed using controlled pulling force, and the thighs are routed to a separate line, all to ensure that each piece of chicken behaves almost identically when it later enters KFC's pressure fryers. From this point on, the chicken enters the most critical stage, where KFC's legendary recipe is finally activated. On an automated conveyor, the chicken moves continuously through the dry coating station, a secret blend of 11 herbs and spices, including salt, black pepper, paprika, garlic powder, onion powder, mustard powder, celery powder, dried ginger, oregano, thyme, and white pepper. The key does not lie in the ingredient list alone, but in the blending ratios and the order in which the chicken comes into contact with them. As the first dry coating is applied, the spices adhere directly to the surface of the meat. The wet coating that follows dissolves part of the essential oils, awakening the aroma. Finally, a finishing layer of dry coating locks the entire structure in place, laying the foundation for the crispy, aromatic, and richly flavored crust that defines KFC's pressure-fried chicken. Once the chicken pieces have been pre-processed and coated at the factory, they are transported under refrigeration to individual KFC restaurants and enter the final cooking stage. In the kitchen, the chicken is kept at low temperatures until frying time, then placed directly into pressure fryers, the key equipment that defines KFC's cooking method. The frying oil is heated and maintained at around 170 to 175 degrees Celsius. Thanks to this high-pressure environment, the chicken cooks faster without drying out. The outer coating becomes distinctly crispy, while the meat inside remains tender and juicy. Frying times are strictly controlled for each product type, after which the chicken is removed, drained of excess oil, and transferred to warming trays. The entire in-store process is designed so that every batch of chicken served has the same color, texture, and flavor, regardless of who prepares it or what time of day it is cooked. Alongside its traditional bone-in fried chicken, KFC has developed small chicken pieces by cutting boneless chicken into bite-sized portions, rather than grinding or molding the meat like industrial nuggets. Each piece remains whole muscle chicken, simply divided into smaller cuts to suit faster eating habits and shareable meals. Thanks to their smaller size, these pieces cook faster and more evenly in pressure fryers. With temperature and pressure tightly controlled, frying time is reduced by around 20 to 30% compared to larger cuts, while the meat inside stays tender, juicy, and well hydrated. At the same time, the coating fully covers the surface, creating a deeply crispy, evenly golden crust that delivers KFC's signature flavor. Cheaper than Pizza Hut, faster than Papa John's, and generating revenue far beyond the rest of the pizza world. That is, Domino's, a pizza machine powered by speed, technology, and scale, with annual revenue of USD 40 billion. The journey of producing nearly 3 million pizzas each day at Domino's Pizza begins with massive ingredient tanks inside highly automated production centers. Like everything in the fast food industry, pizza dough has its own formula. Flour, water, oil, salt, and sugar are measured precisely down to the gram, combined with Domino's Pizza's proprietary recipe that only a very small group of senior executives can access. The mixture is then fed into large industrial mixers, where powerful paddles continuously press and stretch the dough in a fixed cycle. This mixing force develops a smooth, elastic, and uniform dough, while temperature is tightly controlled to ensure that every batch delivers exactly the same result. After mixing, the dough is portioned and rounded entirely automatically. Each dough piece is cut to a pre-programmed weight, approximately 150 grams for small pizzas, 250 grams for medium, and 380 to 400 grams for large. The dough then passes through rollers and shaping surfaces that stretch the outer skin, forming smooth, round, airtight dough balls. The entire process takes less than 10 seconds per dough ball, moving too fast for human intervention. This stretched surface structure helps the dough maintain its shape, rise evenly, and resist tearing when stretched into a pizza base. On each production line, the system can operate continuously for hours, producing enough dough to supply hundreds of stores within the same region. The dough balls for small, medium, and large pizzas are then placed precisely into molded trays, ready for cold fermentation and distribution. Next, the dough enters a massive spiral cooling system, where the temperature is reduced to 3 to 4 degrees Celsius to slow down fermentation without compromising the quality of the dough. Domino's does not operate frozen pizza factories. Every pizza is made fresh at each individual store and sent straight to the customer. In Domino's kitchens, the dough is taken out to naturally return to temperature before being placed on a cornmeal-dusted work surface. The motions of rotating, pressing, and supporting the dough with the back of the hand are not just about shaping, it's about pushing air from the center toward the edge, forming an even rim that determines how the crust rises in the oven. Each pizza maker senses the dough differently. Hand pressure, rhythm, and stopping point are never exactly the same. A skilled worker needs only 20 to 30 seconds, yet can still create a rim that is even, intact, and stable. These subtle variations in technique leave a distinct personal signature on each crust, enough that two pizzas made from the same batch of dough can feel slightly different from the very first bite. Next, the tomato sauce is spread in precise circular motions. Cheese is evenly distributed across the surface, avoiding the center to prevent the crust from becoming soggy or baking unevenly. Toppings are weighed to exact portions, ensuring that every pizza, whether in New York or Tokyo, delivers the same consistent experience. Finally, the pizza slides into a high-temperature conveyor oven and emerges after 6 to 7 minutes, with a golden crust, fully melted cheese, and gently bubbling toppings. During events like the Super Bowl, when millions of pizzas must be sold within just a few short hours, speed becomes a matter of survival. Pizza makers are not just selling food, they are racing against the clock, where being delayed by just a few seconds can mean hundreds of orders falling behind on the biggest sports night in America. Whether produced in the US, Mexico, or Brazil, every bottle of Coca-Cola tastes nearly identical, a feat few brands can achieve. The secret lies in a legendary formula called Merchandise 7X. Only 2 people in the world know the full recipe, and they are never allowed to fly on the same plane. Amazingly, this iconic formula didn't come from a high-tech lab, but from a small pharmacy in Atlanta. In 1886, pharmacist John Stith Pemberton created Coca-Cola as a tonic to relieve headaches. But it was Asa Griggs Candler who acquired the formula in 1888 that transformed it into a global empire. With bold strategies and marketing genius, Coca-Cola became more than just a drink. It became a worldwide icon, now valued at over $96 billion and holding 46% of the global carbonated beverage market, far ahead of competitors like Pepsi. Have you ever popped the cap off a Coke with a st and gulped it down, feeling refreshed? Behind every bottle is an intricate system running like a finely tuned machine. Now follow me as we explore where Coca-Cola is born every second. You'll be amazed. You'd be surprised to know that 90% of Coca-Cola is water. Before it transforms into the world's best-selling beverage, the water goes through multi-stage filtration, reverse osmosis, and UV sterilization, ensuring absolute purity. Once the water has been purified to near perfection, the process moves into its most crucial stage, preparing the syrup, the very soul behind Coca-Cola's legendary flavor. The syrup contains sugar or high fructose corn syrup, caffeine, caramel for its signature brown color, and phosphoric acid to balance the acidity. But it's Merchandise 7X, the mysterious formula kept secret for over a century, that truly makes Coca-Cola unique. Once complete, the syrup is mixed with purified water in massive industrial blending tanks, operating in a sterile environment and monitored by an advanced automated system to ensure absolute consistency and quality. The next step is CO2 carbonation, where CO2 is infused into the water and syrup mixture, creating the legendary cyst sound and a tingling, refreshing sensation that makes each sip of Coca-Cola feel like a burst of freshness. Once perfectly blended and carbonated, Coca-Cola is ready to explode in every drop. The bottle's job is to preserve its refined flavor and begin the journey to conquer the world with that ultimate moment of refreshment every time the cap is opened. With PET bottles, the process starts with small preforms, no bigger than a finger. These tiny plastic tubes are placed into a molding machine, where high heat and powerful compressed air inflate them into the Coca-Cola bottles you hold every day. Aluminum cans, on the other hand, are stamped and shaped from thin sheets of metal, then cleaned, dried, and sent straight down the production line. As for glass bottles, Coca-Cola's nostalgic icon, many plants around the world operate reuse and recycling programs. Used bottles are collected, thoroughly washed and sterilized, and then inspected by high-tech cameras. Only those that pass every checkpoint will be reborn, ready to carry a fresh new round of Coca-Cola. Once the perfect bottles are created, they immediately move into the filling area, where every drop of Coca-Cola is poured in an instant, filling hundreds of bottles and dozens of cans every second. The advanced filling system, under extremely high pressure, preserves the signature fizz and ensures precision down to the smallest detail, preventing any air from entering. Afterward, the bottles are automatically sealed, locking in the freshness and effervescence, so that every bottle of Coca-Cola reaches your hands bursting with flavor. Next comes the step of dressing Coca-Cola. Not simply labeling, but a mesmerizing showcase of precision and high-speed technology. On the modern production line, thousands of Coca bottles move like miniature battalions, passing through an automated labeling system at dizzying speed. Ultra-sensitive optical sensors scan each bottle to ensure the label is applied with millimeter accuracy. After being perfectly dressed, the Coca-Cola bottles and cans begin to gather. On the production line, automated machines arrange them snugly like perfect puzzle pieces, forming neat packs. These packs glide along the conveyor belt like small trains, moving smoothly and steadily, carrying an explosive energy as they race forward. In some special editions, the packaging is designed like a mini suitcase with a convenient handle, not only making it easy to carry, but also serving as an invitation to lively parties and moments of explosive energy. Automated machines neatly wrap shrink film around each pack. At this stage, giant robotic arms swing into action, working tirelessly and precisely, lifting, rotating, and placing each pack onto pallets like a high-tech game of Tetris. Once the pallet is full, a shrink wrap system kicks in, sealing the load like battle armor, keeping the Coca-Cola formation tight and flawless. The blazing red packs stack up neatly and glide smoothly, like a perfect final move in a game. And from here, the journey to conquer the world begins. The lift carefully moves the pallet into the warehouse, placing it neatly like the final puzzle piece in a perfect picture, ready to set off. A 24/7 logistics network ensures that just hours after leaving the factory, Coca-Cola is already chilled on store shelves, ready to pop open with you. Because a glass of Coke isn't just a drink, it's the grand finale of a backstage tech symphony. Coca-Cola and fast food, an inseparable golden duo, with every sip of Coca-Cola perfectly complementing each bite, delivering an unexpectedly euphoric experience. But even the strongest always have a worthy rival. And when it comes to Coca-Cola, one name stands tall: Pepsi. For decades, these two fizzy titans have clashed in what might be the most epic marketing war of all time. From the legendary Pepsi challenge that dared drinkers to choose blind, to Coca-Cola's secret formula locked tighter than a government vault, it's been blow for blow. Billions of dollars, decades of drama, and countless sips later, the bubbles are still rising, and this battle, far from over. Haribo's success has never been accidental, but rather the result of decades of meticulous refinement and unwavering consistency in product philosophy. Even the colors of its gummies are designed according to precise logic. Red appears most frequently because it is consumed the fastest, while green, yellow, and other colors exist not merely for visual appeal, but to balance flavor, consumption rhythm, and the overall user experience. Beyond that, Haribo continuously updates flavors, shapes, and production technologies to adapt to the demands of each market. So what about you? When you open a bag of Haribo, which color instinctively draws your attention first? And every journey has a beginning. Right now, let's step into the very first link in Haribo's gummy production chain, the gelatin factory, where the foundation of every gummy candy is formed. Each day, a large-scale gelatin factory receives between 50 and over 100 tons of raw materials, primarily animal skin and bones. Upon arrival, the materials are inspected for quality and separated into appropriate processing lines. Before further treatment, all raw materials are reduced in size through cutting or grinding to increase surface area for the subsequent processing stages. After being cut into smaller pieces, the raw materials are soaked and washed in large water tanks, combined with continuous agitation to remove blood, fat, and surface impurities, while also hydrating and softening the collagen structure. This is a crucial pre-treatment step that allows the chemical reactions in later stages to proceed evenly and consistently. In this stage, a large volume of wastewater is generated, containing high levels of organic matter and fats. Therefore, appropriate treatment is required to prevent water pollution and environmental impacts. Next, the materials undergo chemical treatment to break down the collagen structure, typically by soaking in an alkaline lime solution for 5 to 20 days, followed by neutralization with a dilute acid to adjust the pH to around 5-6, preparing them for gelatin extraction. At this stage, the material is heated in water at temperatures of up to around 80 degrees Celsius, allowing collagen to gently hydrolyze and dissolve, releasing gelatin into the solution. This process occurs in multiple cycles, producing a protein-rich gelatin solution that forms the foundation of gummy candy's characteristic elasticity. The raw gelatin solution remains cloudy and contains undissolved particles. To achieve the required purity, it is passed through a multi-stage filtration system with ultra-fine ceramic membranes. Under high pressure, microscopic impurities are retained, allowing only purified gelatin to pass through, resulting in a clear, uniform, and stable solution. After filtration, the gelatin is demineralized through an ion exchange system, helping to stabilize its pH, color, and gel strength. Subsequently, the gelatin solution is heated to maintain its liquid state and fed into the vacuum concentration system. The concentration process is carried out at a temperature not exceeding 70 degrees Celsius in order to minimize gelatin denaturation, while excess water is removed to increase the solid's content to approximately 30 to 40%. The resulting solution has sufficient viscosity and consistency for subsequent forming and further processing steps. After the gelatin solution is cooled to a semi-solid state, the elastic mass is pressed through perforated metal plates with precisely controlled openings, forming long, continuous gelatin strands. This extrusion is carried out under stable pressure to ensure uniform strand size and structure, which directly affects the gelatin's solubility and gel strength. As the material passes through the plates, the protein structure begins to set, transitioning from a bulk mass into flexible strands. The strands then fall onto a conveyor belt and are dried with sterile hot air, removing most of the moisture while preserving the protein structure that gives gummy candy its characteristic elasticity. After drying, the gelatin is ground into a fine, uniform powder for easy dissolution and precise dosing. From here, the gelatin is bagged and sealed by batch, ready for immediate shipment to food manufacturing facilities worldwide, as delays and exposure to moisture or temperature fluctuations can reduce solubility and elasticity, directly affecting final product quality. And now, let's move on to the most anticipated part of the journey, where gelatin is no longer just a raw protein powder, but is activated on Haribo's production lines, transforming into millions of chewy gummy candies found on shelves around the world. At Haribo factories, the candy production process begins with the careful selection and precise weighing of key ingredients, such as gelatin, sugar, glucose syrup, water, food acids, flavorings, and colorants. These ingredients are then fed into the mixing system according to pre-programmed formulations, strictly adhering to Haribo's proprietary recipes. From the very first stage, each batch is closely monitored to ensure absolute uniformity and consistent quality across millions of finished candies. After dosing is complete, the mixture is transferred to industrial cooking kettles and heated using high-pressure steam. Under controlled heat, water evaporates while sugar and gelatin fully dissolve. Within just a few minutes, the mixture becomes a smooth, uniform liquid syrup, ready for the next stage of structural stabilization. After cooling, the syrup is tested for bricks using a refractometer to ensure the sugar concentration and consistency meet the required standards before shaping. At this stage, the base syrup is divided into multiple streams for color and flavor blending according to each product. Haribo produces dozens of different flavors, with sour varieties such as cherry, raspberry, and grape, requiring precise acid control to deliver a sharp taste while maintaining gelatin stability. In parallel with flavor preparation, molds are formed directly on the mogul machine using cornstarch blended with mineral oil. The machine spreads and levels the starch, after which stamping heads press the candy shapes into the starch bed, creating hundreds of soft cavities on each tray. The cornstarch not only holds the shape of the candies, but also absorbs moisture from the hot candy mass, allowing it to set slowly and uniformly, an essential factor in developing the characteristic chewy and elastic texture. When the starch molds are ready, the gummy syrup is transferred into central depositing hoppers, where temperature and viscosity are tightly controlled to ensure precise flow. An automated depositing system then dispenses exact amounts into each mold cavity with minimal deviation. Throughout the process, sensors monitor syrup temperature and flow to prevent underfilling, overfilling, or air entrapment, allowing Haribo to maintain consistent gummy quality even at massive industrial scale. After depositing, the trays are stacked and moved into curing rooms for approximately 18 to 24 hours. During this time, the cornstarch continues to absorb excess moisture while the gelatin fully sets, forming a stable, chewy, and elastic structure. After the curing stage, the trays are inverted over vibrating screens, allowing the gummy candies to separate from the starch molds and continue along the production line. The remaining cornstarch falls into a recovery system, where it is cleaned and reused for subsequent batches, improving overall production efficiency. The gummies are then transferred into slow-rotating drums, where they gently tumble and collide with one another as the drums turn. This motion removes any remaining starch residue from the surface, while rounding the edges and evening out the shape of each candy. Once cleaned, a thin polishing layer made from vegetable oil, combined with beeswax or carnauba wax, is evenly applied inside the rotating drums. This coating prevents sticking, enhances surface smoothness, preserves color, and gives the gummies their familiar dry, pleasant feel. A small detail that plays a key role in the signature Haribo eating experience. Finished gummies are randomly sampled and inspected for shape, color consistency, flavor, and chewiness to ensure each batch meets Haribo's standards. Selected samples undergo additional testing for elasticity and heat resistance, confirming that the gummies maintain their characteristic texture and stability during storage and distribution. Only products that pass all checks proceed to packaging. Finally, Gummies that meet quality standards are fed directly from the conveyor into a fully automated packaging system, where multi-head weighing hoppers continuously portion the candies according to precisely preset weights. Each hopper calculates the optimal combination in real time, then releases its measured load straight into individual bags in a split second, ensuring uniform fill levels and minimal variation even at extremely high production speeds. Once filled, the bags are immediately heat-sealed, labeled, and passed through metal detectors to eliminate any risk of contamination. They are then packed into cartons, shrink-wrapped, and stacked onto pallets, ready to enter Haribo's global logistics network. This seamless, end-to-end automated process enables millions of Haribo products to leave the factory every day, supplying retail shelves across hundreds of countries worldwide. Notably, every Haribo gummy is engineered to deliver a chew time of approximately 20 to 30 seconds, significantly longer than fast-melting candies. This extended chewing gradually releases sugar and flavor, creating a smoother sweetness, less taste fatigue, and a consistently satisfying eating experience, no matter where in the world the candy is enjoyed. After the sweet corn is harvested from the fields, it's quickly transported to the processing plant to ensure its freshness. Here, the corn goes through a careful and precise processing procedure to ensure the highest quality products are delivered to consumers around the world. When the corn arrives at the processing plant, each ear is moved along a conveyor belt to an automatic husking machine, which removes the outer husks and corn silks. At the same time, the corn is washed with water or steamed to clean off dirt and impurities. Once the corn is cleaned, it is carefully inspected to ensure it meets quality standards before moving on to the packaging stage. The corn that meets the standards is neatly arranged into plastic trays or vacuum-sealed bags to preserve its freshness. Then, it is labeled, packed into boxes, and ready to be distributed to supermarkets or stores around the world. After the fresh corn is packaged and stored, some of it is sent to the processing line to make canned corn. Here, the corn goes through specialized machines that separate the kernels from the cob, ensuring that the kernels are removed whole without breaking or damaging them. This process is done with great precision to maintain the quality of each kernel. After separation, the kernels are thoroughly washed to remove any dirt, impurities, and leftover bits from the harvest and cleaning stages. This ensures the corn meets food safety standards. Next, the corn is briefly boiled in hot water. This step not only helps preserve its freshness, but also enhances the natural crisp sweetness of the kernels. After blanching, the corn is rapidly cooled using a hydrocooling method, either submerging it in cold water or misting it with chilled water, to prevent further cooking and preserve its crisp texture and bright color. This sudden drop in temperature slows enzymatic activity and inhibits bacterial growth, thereby improving food safety and extending shelf life. After the corn is boiled, the kernels are placed into sterilized cans to ensure cleanliness before the corn is added. The cans are then filled with corn and either salt water or syrup, depending on the final product the factory aims to create. Once sealed, the cans go through a high-temperature sterilization process to kill any bacteria or germs that might be present, while also extending the shelf life of the product without compromising the corn's natural flavor and nutritional value. After sterilization, the cans are labeled with product details and necessary information, then packed into boxes for shipping. These boxes of canned corn are sent to stores and supermarkets, ready for consumers to enjoy a convenient, delicious, and nutritious addition to their everyday meals. In addition to being canned, corn is also turned into popcorn, an incredibly popular snack. The popcorn production process starts with selecting high-quality kernels and removing any that don't meet the standards. The corn is then sent to a popcorn machine, where the kernels are heated to a high temperature, creating pressure inside and causing them to pop. Once popped, the popcorn is mixed with seasonings, including salt, butter, or other flavorings depending on the product. This mixing step ensures even distribution of seasonings, creating a consistently flavorful snack. Afterwards, the popcorn may be coated with caramel, chocolate, or chili, resulting in a shimmering color that appeals to a variety of consumer tastes. After cooling, the popcorn is packaged into bags or boxes, ready to be distributed, offering a delicious and crunchy snack for consumers.